Hello everyone, welcome to this Siemens SA16 safety controller series video. In this video, I will mainly introduce the light curtain control in this robot cell. Use this robot cell as an application background and use the SA16 safety controller as well as the light curtain safety logic to program the safety control. In previous video, we used the safety application, this example scenario 19 as our example. Also, we used this cell as our application background to introduce the safety function and the door switch function, as well as the station control enable safety relay control function. We used the EStop, door switch, as well as the feedback function block. And in last video, we introduced how we can program the EStop function, how we can set the configuration according to this the safety switch with the OSSD function. In this video, we will mainly introduce the light curtain safety control, especially used in this robot cell with a turntable safety control. Generally speaking, in the robot welding cell, most of the cell need light curtains. Usually, the operator need to load the parts on the turntable, and after they finish the loading, once they come out, press the pump out button, and the turntable will rotate. Once the turntable rotates in the cell, the robot will go to the working area and start to weld the part. Meantime, the other side already turned out towards to the operator, and that time operator can load the part at the other side. So as we can see, because the operator need to work at this area, and at this area we have a turntable and the tooling system towards to the operator side. So we do need a light curtain to protect the safety of the operator. So usually we will mount the vertical and the horizontal light curtains at this area. And because this light curtain will also involve control to this turntable, you can imagine when the turntable rotates, if someone broke the light curtain, the turntable must be stopped. Also, the tooling system towards to the operator side, they also need to disable by the light curtain. But if the operator broke the light curtain, the robot and the tooling inside the cell will not consider the light curtain. So that means usually the EStop are very straightforward, but the light curtain need to involve some logic. So it will be a different logic to control this area. So let's go to the hardware portion firstly. Usually the light curtain used in the robot cell or used in the industry, most of the light curtain, they are OSSD function. So that is the similar function or similar wiring as this door switch. Usually, the OSSD1 will connect to the lower address channel, which is on the top of this module, and the OSSD2 will connect to the higher address channel. Those two channels are paired. And the power supply of this light curtain will be supplied by external power supply. And from the function block logic wheel, if we quickly go through the safety function block, so you will find that there's no specific function block named light curtain served for the light curtain function block. See? However, from the logic wheel, actually the EStop function block can provide a similar function as the light curtain needs. If we broke the light curtain, you give the signal go off. It's similar idea as a EStop. So most of the case in the safety controller system, to program the light curtain, most of the programmer will prefer to use the EStop to connect the light curtain and use the two channels bundled together, set the discrepancy time on that paired channel. So that is the main idea to program the light curtain. So according to our case, let's go back to this hardware configuration. We assume we are going to use two light curtains. One is a vertical, one is a horizontal, and each light curtain, it has a OSSD1 and OSSD2 channels. So let's go to the input module. So if we record the channel 0 and 8, they are already assigned with a 1002 evaluation. They are connecting with a EStop button. And the channel 1 and 9 connect with a door switch. So the next one, the channel 2 and 10, we will connect with a vertical light curtain. So let's firstly activate these two channels. Okay. To connect this OSSD light curtain, usually we will select a 1002 evaluation, allows the hardware to judge the discrepancy time for this light curtain. And we will select the two channel equivalent. That depends on the light curtain you are going to use. This discrepancy behavior, we will select the 0. And this discrepancy time, usually we will set a little bit higher value, for example, from 200 to 500 milliseconds. Okay, so in this case, we will set 250 milliseconds. And we will leave this test 0 signal not necessary. And for this sensor supply, because usually this OSSD light curtain will be supplied by the external power, so we will select the external. So we bundle those two channels together. That is used to connect the vertical light curtain. And next one, that is a horizontal light curtain. So we will set the same thing, active these two channels, select the sensor supply to external, and we select the 1002 equivalation and select the two channel equivalent and set the same thing to 50. Okay, we finish the hardware configuration. And then we go to the I/O tags. So for the first light curtain channel, 8.2 and 9.2, they are already bundled together. So for this input, I will name it vertical light curtain. Light curtain vertical. And the channel 8.3 and 9.3, they are already bundled together. So we will name it light curtain horizontal. So let's go back to the programming wise. So to program the light curtain, we will create a new function block. New block. We named light curtains. Okay, so function block, safety enable, select the manual number, which is 12. Okay, light curtain from here. If we look at this function block library, there's no special function block for the light curtain. From application wheel, usually we can use the EStop function block connect the light curtain. So let's drag this EStop function block. But we will name it like this. So light curtain, select this multiple instant. Light curtain vertical. Okay, so next, multiple instant. Light curtain horizontal. Okay. And for this vertical input, we will use our input. We will select this light curtain vertical. And next, for the horizontal, we will select input 8.3, light curtain 8.3. To recover, and for this function block, it need acknowledge necessary, which usually we need to select to true, because if we record this application, so if someone go into this area, he will break the light curtain and the signal from the light curtain will go off. Once the operator go outside, without press the pump button to acknowledge this area clear, the light curtain signal from this function block output must be off. until he presses the palm out button, acknowledge this function block, and then this function block output will go on, right? So that means the acknowledge must be true. We need acknowledge this signal. So the acknowledge signal for the horizontal and vertical could be the same. So we will set acknowledge signal, let's say SAK light curtains. Okay, that is the bool signal. Okay, we drag it here. We do need a signal from the safety or from the normal standard PLC. Usually that is a palm out button signal. Okay. For this time delay, usually we set 100 milliseconds or 200 milliseconds. We will give a little bit of tolerant time here. That's because according to the robot cell, we will use the robot cell as an example. Usually, we don't want the light curtain too sensitive because once the light curtain break, we will stop the turntable. But if a small tiny things dropped in the light curtain area, we want to give the light curtain a little bit of tolerant time. Because usually, if the operator actually load a part in this area, from the outside go into the loading area, it must be greater than 100 milliseconds, his speed, right? So 100 milliseconds delay time could be acceptable. Another reason we don't like the light curtain signal too sensitive, that's because if someone break the light curtain while the turntable is indexing, so that time we need to EStop or stop the turntable as soon as possible. So that could cause the gearbox of the turntable broken. So we need to consider the mechanical things can be acceptable for this signal sensitive. So we set 100 milliseconds. It totally depends on your application. I just explained this special condition. So for this output, the same way, we will select light curtain dBq. So we drag this vertical Q signal to this area and dropped this Q to this. And usually in your system, if you have a light curtain vertical and horizontal light curtains, we will grab this two curtains signal together, give a summary result, say light curtains clear or light curtains okay signal. So we will put here and give a final output signal. That output signal, let's define here, light curtain. That is the final output of this function block. And usually to acknowledge the light curtain to clear, we will not use the global acknowledge, because usually that global acknowledge button is on the MCP panel, and that MCP panel may be at the back of the cell or on the side of the cell. So the acknowledge signal to clear the light curtain, usually in the industry area, we will put a pump button here. That pump button could be a two-hand switch or could be just like a finger style pump button. And usually, according to the different safety level, the pump button could be connected to the safety module or come from the standard channel, come from the standard PLC. And usually, to connect that pump button, we will use the two-hand switch function block. So if we go back here, let's create one more channel. Let's program the one more channel here and use the two-hand switch. Okay, let's select the multiple instant. Palm out button. Okay, select. And this function block is very simple. If we look at the detail of this function, so this function block check the timing of this two channel. It needs these two channels present at the same time. So that's why usually the palm out button has two channels. So for example, we just give a name. So just an example, we name this first channel, that is the palm out channel 1. And the palm. So currently I'm using the normal standard PLC input. And for this enable, we give a true signal for this enable. And this discrepancy time, we can set, for example, 100 milliseconds, right? And this output, we can set palm out.q. And this output, we set a palm out underscore q. Okay, that is a bool signal. Drag to here. And we use this palm out button to give the acknowledge signal to the light curtain. So we can switch the position. We give this palm out button to give an acknowledge signal. So which means the palm out button connect to standard channel, and once we press this palm out button, that palm out button will give an acknowledge signal to clear the light curtain. If the light curtain already cleared that area, so this output will turn on. Turn on will give a final light curtain OK signal to on. So this is the function block for the light curtain. If we go back to the station enable area, so in previous video, we already introduced to control the final output, especially for the output relay, the core function block we will use, that is a feedback function block. And in the previous network here, we will organize the control logic here. And in this function block, we will connect the feedback, that EDM signal from that relay. On the Q byte, we will connect this value status signal here. And the final output, this underscore Q, will use to control the final Q signal. So for different output control, they are almost the same, because whatever for the robot, tooling system, or wire bank, or the airflow control, we will use the relay or safety relay as the final output to control or supply the power to those different area and different equipment. Ideally, all the safety output control, especially for that relay, has a EDM feedback signal. We need to use this function block, feedback function block, to connect and control this safety output. Since in this video, we will mainly introduce how we can involve the light curtain into our safety logic. So I only take this one function block as an example. For other output, I will not program the feedback function block there. I will use this cell as our application background and mainly introduce the safety logic. So let's firstly program the turntable control. So for the turntable, we do need a EStop and a door switch. Let's firstly program this. That is the turntable enable command. Okay. So other than the EStop and the door switch, we do need to involve the light curtain OK signal to enable the turntable. So we need to use the instant DP from that function block. Oh, we haven't called that function block yet. So let's go to the IP1. And so that station enable is turned red. It doesn't matter because we are programming that station enable now. So let's add one more network here. Let's drag that light curtain. And assign the light curtain instant DB. That is a single instant DB. We manually change the name to 12 instant DB. Okay, so let's go back to the station enable. And from here, to use that light curtain's result, let's use this instant DB from the light curtain. Light curtain SDB dot light curtain OK. Light curtain's OK signal. So that is the control command to control the turntable enable. So next one, that is the tooling in A side. Okay. So let's think about this example. If the tooling at the A side in the cell, at that time, this safety enable signal will not carry this light curtain. But if the turntable rotate A side towards to the operator side, if someone break the light curtain, the tooling on A side must be disabled. According to this, let's program. So let's firstly name a tooling A side. Enable. Okay, we need to use the door switch and the EStop. So we will give a direct signal to here. So which means the table turntable A side in the cell. In the cell. So I rename this A underscore side, which means if the tooling at A side in the cell, so the tooling at A side will not care about the light curtain. Only EStop and the GateSwitch will disable this tooling at A side now. But once, if this turntable are not in the cell, which means maybe this turntable is indexing on the way, or maybe that towards to the operator side. These two conditions. So that time we will need to consider the light curtain. Right? So let's think about this picture. If the turntable is indexing or towards to the operator side, so that means that moment we need to consider the light curtain. If the light curtain drop, so the tooling must be off. If the turntable A side already inside the cell, if you drop the light curtain, it doesn't matter because this already on. Only the EStop and the door switch will disable the tooling. B side is similar. Let's program the B side. Okay. Maybe some friends will ask where that turntable direction signal come from. Usually we will use the sensor, that sensor with a OSSD function mounted under the turntable, and it represent the A side or B side towards to the inside of the cell. Then we can use two-hand switch function block or EStop function block connect that two channels of the OSSD signal. And we can set a false on that acknowledge necessary because that is a switch signal. The acknowledge signal is not necessary. And then use this function block output connect to this direction signal here. So that is the safety enable signal for the A side or B side on the turntable. They need to involve the light curtain signal. And after we program the turntable tooling at A side and tooling at B side, there's three network. So don't forget, we also need to program the function block, feedback function block, similar style like this, to control the final output. So to simple the program to demonstrate, I will not program this area, so they are the similar idea. Once we finish this station enable, don't forget go back to this main FB1, because in this FB1 we call this station enable, and because the inside this station enable we add something inside, so this instant DB will show like a red. We only need to right click and click this update block code. So after we update, they will show correct. So after that, let's compile. Okay, so once we compile, we find there's no errors and no warnings, which is good. So let's go back to the safety administration, look at the timestamp. So once we compile the safety, it will show the current timestamp you have, and it will give you an offline signature here. So usually from application view, after you finish one project, we will do a safety check from the safety engineering will come to the cell and look at this signature, check all the safety functionalities, and look at the drawing, look at the design, and check out your programming. So once they verify and validate the functionalities of the safety program and the safety function, so they will check out this signature and make a report for the safety area. And once you complete your safety program, make sure you set a password on your safety controller. To set the safety controller password, let's go to the access protection here and click this setup. So for example, we will name it CPU 1215, capital CPU 1215, capital CPU 1215. Okay, so once you set a password, you will see a log here. If you click this log off, the safety area will be locked. It still allows you to look at the logic, which is fine. But if you try to change the logic, the system will pop up this window. If you don't know the password, there's no way to change the safety logic. If you know the password, for example, our password that is a CPU 1215, let's click OK. So it allows you to change everything, and this log will be opened. And after you change the safety logic, don't forget to click this log off. That will lock this safety area. Okay, that is set a password on the safety controller. Alright, this is all today. In this video, we mainly introduced how we can use the safety function to involve the light curtain signal. We used this cell as an application background, introduce how we can program the turntable and the tooling on A side and B side using the light curtain logic. So in next video, I will show the door switch. As you know, this is the common style used in the robot cell and the industry cell. And in this door switch with a guard locking function, it will have the EStop button, cell enter request button, reset button, as well as some indicators there. It do need some control functions inside your PLC. Some will be in the safety logic, some will be in a standard logic. So in next video, I will show how we can program and how we can implement this function. See you in next video.
Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe. See you in next video.